Hi and welcome to another Unity 5 tutorial. Today I've had my first request for a tutorial. This is for Capone Williams. Thank you for the idea. So he'd like me to create a 2D air hockey game. And I won't create the whole game, but I will give you a good head start on how to do it. So first of all, we've opened up Unity and I've created a 3D game. Now this will be a 2D game, but we're going to make use of the physics system, and for that I like to work in 3D. So first of all, we need a top-down camera. So we will have a camera. Let's select the camera here, and we're going to set it to, first of all, orthographic, which will automatically go to 5, and that's what we want. We'll leave it like that. And then in the scene, we're going to look down the y-axis so that we're looking from above down on our hockey field, which means that gravity is actually going into the screen downwards. So we'll use this to our advantage. So we've got that now. What I'm going to do is switch over into Android mode so that we can see our portrait screen that we're going to use. So switch platform, because you can't get portrait in your preview if you don't have that. So we're in Android. Let's just switch to game, and here you can select from one of the portrait settings depending on which one. We might go a bit smaller for now. Now the camera, as you can see here, isn't looking down the y-axis yet. Our scene is looking down the y-axis. So we need to align the camera with the scene. So select the camera, and then we will go game object, align with view, which will have us looking directly down on our scene. Now the first thing to do is to create the ground. So we'll use a 3D object for that, and we'll select a quad. Now the quad, when it first arrives in our scene, is actually standing upright on the ground. To see it in this top-down view, we need to rotate it by 90 in the X. Now you can see it there. If you switch to game, you'll be able to see it there as well. And we want to size this. So if we hit the R key, we can then just make this as big as we need it to be so that it fills our screen. Okay, good. Now some texture on that would be nice. I've got a texture I used before, which is this grass texture. So I'm just bringing that in from my desktop. And I can just drop that onto the hockey field. So here's our hockey field. And if I just move around a bit, you'll be able to see it. If we have a look in the game view, it's kind of running the wrong way. We want it to run up and down the screen. So we just need to grab this quad and rotate it around. Now, if you're not sure which way to rotate things, what I like to do is to actually grab a hold of it in 3D and then rotate it like this. And then at the same time, look what's going on over here. So you're rotating around the y-axis, which is what we want. And we're going to be rotating it by 90 degrees. We know that, if you know, remember your geometry. And so this value here is going to be something close to 90. And so let's go 90 like that. Switch back to game. And we can see it there. There's our hockey field. Now, if we put our game view next to our scene, it might make life a little bit easier with sizing things. Okay, and then if we just hit the R key and resize this, you can get your field fitting nicely within the camera's view. All right, so there's our field. The next thing that we need for this hockey game is a puck to shoot back and forth across the screen. So for that, I'm going to use another 3D object. So we'll go to Game Object, 3D Object, and we'll select a cylinder, because we can make that into a pretty convincing hockey puck. So if I just zoom in a little bit here, what this cylinder now needs is a little bit of resizing. So we're going to shrink it down and bring it up. Now, because you can't see how high it is from this top view, it doesn't really matter how high you make it. It could just be a whole full cylinder and you wouldn't be able to tell, except I guess from the shadows. So I guess that's up to you. So we want it to sit above the ground there. And we're also going to add in a rigid body for this so that the physics will work on it. Right, I want to add a bit of colour to this, so I'll just create a material and we'll call that red and colour it to be a red colour. Oop, not black, red. Okay, and then we can drop that colour onto our puck. The next thing is we're going to create some code that allows us to pick this puck up either with a finger touch or with the mouse and flick it around the screen. So to begin with, I just want to put a tag on this because the code is going to detect when we've hit something that's called a puck or tagged with puck. So if we just create this puck tag and then assign it to here, okay, it will only detect when we're touching the puck object. Right, next we're going to create some C# code and let's call this move puck and just open up that. Let me make this a bit bigger for you so you can see what's going on. I just resize like, oh, probably a bit too big. Now imagine you can see that code there. Now I'm just going to copy and paste some code that I created earlier, which will save me a lot of typing. Of course, you can pause the screen when you want to type this out. Okay, here's our code. Just indent that. A bit of a stickler for formatting of code. Right, so this code is going to be attached to our puck. Before I go through it, let's just check that it's working. So we save it and then I'll just flick back to here and attach it to the cylinder. Now, while I'm here, I probably should change this, give it a name so we know which one we're talking about, and then run. Whoa, okay, we saw that, it works. It also ends up flicking the puck. If you have a look on the scene view, that when you flick it like that, it actually rolls, which is not what you want. And it has a capsule collider on it, which is a little bit annoying because it doesn't have a flat bottom. So to fix that, we're going to constrain it from rolling. Okay, with it selected, the puck, let's just go over to the inspector. And the rigid body that's on that, we will restrict it. So we want to freeze it from rotating around, which direction? The red axis, which is this one. So when it rotates that way, over and over, it's actually rotating around this one as though it was on a axis, I guess, like a spinning wheel. We don't want it to rotate around this way either, which is our z-axis. So if we have a look here, we've got our red X and our blue z-axis. The only axis we want to allow this to spin around, if at all really, because it's just plain red, if it does spin you wouldn't see it. But I guess if you want to put some sort of texture on it, you would see it then spin. We want to restrict it anyway to spin only around the Y. So let's just freeze the constraints of the rotation for the X and the Z in this case. Now, if we run again, we should be able to flick it like that, and it won't rotate. It will, though, go off the screen, and we'll fix that up in a moment. So let's have a look at this code. Okay, so this is the code called move puck, and it's attached to the puck object itself. Now, this code can be attached to any object, which will allow you to flick it around on the screen. So it's not set specifically for the puck, but any object that is tagged with puck that you add this to will work. So I'll go through it. It's basically and only, yes, an update function. And we've got some variables at the top here. We've got a focus object. This is our variable that's going to hold on to the object that we've touched or put the mouse on. And then we're going to register a last position for our object and the last velocity for the object, which will be used to calculate the direction and the movement of the puck itself. Okay, moving down inside this update function, we've got our input get mouse button down. This is the touch phase. This is when we first click on it. We've also got code here for mobile. So you can also run this on mobile. Input.touch count is greater than 0, means that there's been more than one finger on the screen. You could put equals to 1 in this case if you want to restrict it to one touch. And we're going to check the phase of the touch that it's only just begun. So touch phase.began or mouse down. So this is the first instance our puck has been touched, or the screen has been touched. When the screen is touched, we then create this raycast, which is a line that goes directly into the screen. And we call it a ray. It starts at the position of our finger and goes straight down the y-axis, because remember, we're looking straight down the y-axis with our camera. Okay, so we then do a physics raycast, which tests whether this line we have injected into the screen has hit something. If it doesn't hit anything, we just throw ourselves out of the update function because we don't want to do anything else. If we have hit something, it will continue and test if the thing we hit was tagged with puck. Okay, here, which is important because you can also touch the screen and hit the ground. You don't want to be able to flick the ground, so we just want to pick the puck. We then set the focus object variable to the object that we touched, the puck object that we touched, so we now have hold of it. Right, now when the mouse button is now up, released, or the touch phase has ended, that means we've let go of the object, we're going to add a force equal to the last velocity that was registered multiplied by 1,000. So we've given a bit of juice in this case. And then we're setting focus object to null, which means we've let it go. And so our code is also letting it go. So that's when we put our finger down, and this is when we release our finger. Now, this last velocity is important. It needs to be calculated. And it's worked out based on where we recorded the finger last moving or the mouse last moving, the direction of that. And that happens down in this last part of this else statement, which is this bit here. So if we have hold of an object, if focus object is not null, and our touch phase is moved, or we still have the mouse button down. Okay, so this will just register if we've got the mouse button down and we're moving the mouse around. Otherwise, this will check if our finger is still moving. So it hasn't been released, it's still moving. Now, after it does that, it then calculates a position based on where the camera is. So we use this function, camera.main screen to world point. This translates the position of the mouse, okay, so the mouse at the XY of the screen coordinates, and makes it a value in the 3D space. So the 2D space is the screen you're looking through. It has a different set of coordinates to the 3D world, which makes working in this environment quite tricky. You have to constantly change your values from one viewpoint to another viewpoint. And this will take where we've touched and make it into the world position, which puts it into here. We then set the focus object's position to the location that we just touched, or the one we calculated that was in the world below where our finger is touching. And we're going to use the X position of our finger and the Z position of our finger to update where the puck is, not the Y position. Okay, we don't want to change how high the puck is from the ground plane. We're going to keep it at its own height. We're just using X and Y. And if I just switch back to here, okay, we're looking at this scene. This is our X movement for the puck, and this is our Z movement. So we're moving in all the directions we need this puck to move. It's not going to move up and down here. We want to keep that constant. So this will do it. This is why this is in the Y area. All right, we then update our last velocity, and the last velocity is set on the last position, taken away from the current position. That will give you basically a direction in which the puck is traveling while you're touching it. And then it updates our last position so that next time we do all this calculation, the puck is in the new position. And then when we release our finger, the puck will continue to move on this line here in the direction that we were moving it. Right, so once you've typed all that in, you want to save it. You want to attach it to the puck and then run it. Test it out. Build it out to your device if you want to. Okay, it's moving quite nicely. Now, you may have noticed one small problem with this game so far is that if you flick the puck too far, it will fly off into infinity, which we don't want. We want to keep it in our screen. So we can actually just build some physics barriers around this grid, which will keep the puck there. Alternatively, we could also calculate the position of the puck and keep track of where it is with code and keep resetting it, which is probably more difficult than we need at this point. So what I'm going to do is I'm just going to zoom out here a bit. And just to be nice and neat and tidy, let me put the puck back in the centre. Does the puck start in the centre in hockey? I'm not sure. I guess it does. Right, so let's add a cube. There's our cube. And it's going to be one of our barriers. So we're going to move it over to here. Now, see it in the game view. Let's say we want the puck to be there on that line. You just want to be able to see it in this game view. Now hit the R key. Let's make it nice and big. And we have one collider. Control D that. And then hit W and we can move it another one over to this side and line it up there. Okay. Now if we run this and we bounce our puck around, you'll see that, oh, it's not very bouncy. Whoop, and there it goes off the end. Okay, so we've got those ones. And we can now add another cube and use that up here. The reason I'm keeping it so that you can see it inside of here is that you know where it is. Because sometimes if it's way off, it'll get lost and you can't see it and it gets confusing. So let's make that barrier out there and then Control D and move that down. Now you'll notice that we can still see this and you don't want to see it. So once you've created all of your barriers, you can select them and then turn off their mesh renderer. Please do not add rigid bodies to these because they do not need them. Now our hockey puck will stay within the confines. Oh, unless you purposely flick it out through there like there, which won't happen because if you're playing this, your mouse won't be able to go beyond the mobile screen like mine just did. I saw your finger. Okay, let's add a bit of interest in here. We probably want to make these barriers a bit more bouncy. So let's select one, I want this side one here, okay? And we will make a physics material. So create physics material down here. You can't see that's off your screen. But trust me, under create, down just below my screen, there is a physics material. Click on that, and we're going to set bounciness. So let's just go over the top here and set it to 1. Okay, and then set this material name to bounce. All right, and we're going to add that to the physics material here. Okay, bounce. And you want to do that with all of these cubes. So the top one, and then the side one, and finally the bottom one. Right, now when we run this, we should get a bit more interesting thing happen. Yeah, see, so that's going to bounce nicely now. This could almost become a pinball game. Right, so before we start scoring this game, we need some scores on the screen. So I'm going to add those in. In the hierarchy, we're going to go UI and add some text. Yep, and you'll see the new text come up down the bottom here, which is quite difficult to see because it's the default text. And I'll just see if we can find it here. So this is our UI, and our text, we probably want to make it look a little bit more fancy. So I've got a font I found, which is called Hamburger Heaven. I'll just drag this into here. I think I got this from freefonts.com. They've got lots of great fonts if you're looking for those sorts of things. Right, with the text selected over in the inspector, we can find the font that's being used. So by default, we get Arial. If you want to use Hamburger Heaven, we can drag that and change the font. Still very tiny. So we can just increase it. Oh, not that much. Now, when you do increase your text, if it disappears like that, it's just become too big for the little box that it's sitting in. So if we increase our size like this, you'll see that it gets bigger. Okay, and we want it to be white, so let's set that to white. And it's going to say score. Okay, so there's our score text for one player. If you want to center this, then you can select this area here. That's in the inspector, and you can make it snap, I should say anchor it to a particular pivot point so that when you change the size of the screen, it stays kind of relatively put. If you want to actually move it to a position, you can hold down the Alt key and click on these things, and it will move them to where you want them. Now with score, let's just put it over in this corner for that score. So this is player 1 score. Once you've anchored it to that sort of position, we can then just move it across just a little bit like that. To make the score for the other player, if we just select this and duplicate it, we can move another copy up to there. Okay, remember we can also go into here and use the Alt key to position it like that, and then just move it across and down as much as you can so you can see it there. Right, so this is the text that says score. The text that's going to actually become the score is another piece of text. Okay, since we've already got this, we will just duplicate it again. Just move it over a little bit, just in one direction. We'll keep it aligned. And this one here, we will change the name of, otherwise this will get very confusing really quickly. And let's call this top score. Not as in the higher score, but at the top of the screen. And let's set that to 0 over in here as its text. And then we'll do the same for the one at the bottom. We will duplicate it, move it across, and then set it to 0 after we call it bottom score. And let's make that 0 as well. Okay, so there's our 2 scores ready for updating. The last thing we're going to do is to update our score based on the puck moving inside this goal area or inside this goal area. So to register when it goes in here, we need a collider. So let's create a 3D object cube. The old cube is very useful for creating a very quick collider. Let's move it up into the goal area and we will resize it just to make it a little bit bigger. Let's see which axis I'm grabbing. Okay. When you're done, you can turn off the mesh renderer. It will still be there and act as a collider for the puck. Now, it's not going to be a physics collider which will hit the puck and have it bounce off. We want the puck to pass through it and register when that happens. So let's set its box collider to a trigger. Now, if we just at this point play and flick our thing through, you'll notice it goes through. This collider now needs a script that's going to link it to the score here so that when the trigger is hit, the score gets updated. So create yourself a new C# file and call it scores. I've already got one here. Might have noticed it magically appearing during one of my editing cuts. And if I just open it up, I'll show you what's in there. Okay, so here it is, nice and short, is we're going to link that text that's sitting on the UI to here and call it score display. Then on trigger enter, when something collides with our goal, which will be the puck because that's the only thing that's moving in this game, if you had more things colliding, you would have to put an if statement here and check for what the tag of the object was before you go and update things. We're then going to update the text part of our score, so the text component. What we update it with looks a little bit tricky or complicated because of the way you have to work it out. First of all, you have to get the text that's in that text box. So at the moment it's 0. So we're going to get that text. We're then going to convert it to an integer with this int.parse function. Okay, so now it's an integer. We're then going to add 1 to it. So if it was 0, it will now be equal to 1. If it was 1, it would now be equal to 2. Now you can't put an int straight into a text field, which is a string. So you then need to convert this int back into a string. And the really simple way of doing that is to put a plus and an empty string on the end, which will make the whole thing a string. So it grabs the text, turns it to an int, adds 1 to it, then turns it back into a string and sticks it in the score that's on the screen. Okay, so you want to save that. Flick back to Unity, grab your score and attach it to your goalpost, which is unfortunately still called cube over here. I'm very bad at naming things, but we should get into a good habit. Let's call it goal top. And score is now attached, as you can see in the inspector, and it's waiting for its text field to come in here. Now this is the one we call top score. Let's drag that over and dump it into there. Okay, so if we run this and we use our puck and go in there, you'll now see it updates the score. If you want the score to go up by more than 1 at a time, you would go in here and change this value here. That doesn't keep adding 1. You might add 10, could add 5, whatever you want. Okay, we're going to do the same thing at the other end. We're going to create another goal. Now we can duplicate this, I think might work. Okay, and then this one here, let's call it bottom so we know the one we're working with. And let's move it down the other end to there. Now, when it's selected, if we go over and have a look in the inspector, we've got our score script, but it's still pointing to the top score. So we're going to add bottom score in there. Drop that there. Okay, now when we run, we should be able to get a score down there and a score up there. And if you build this out to your Android device, it will work with finger touching as well. Finally, you might just want to turn these mesh renders off. Where are we going? There. Okay, and that's pretty much the beginnings of a very simple table hockey top-down 2D game. Okay, there's a lot of 3D elements in there, but as you'll have seen, we use those to our advantage because we want to use the physics system. As long as we keep control of the physics system, it can become a really good friend to us. So, Capone, I hope you enjoyed that, and everyone else who's watching, stay tuned for the next tutorial.